Hi, Mrs. Landberg here, and this is lesson 2 for rounding whole numbers. You need to have your math book, and it needs to be on page 37. You also are going to need a pencil and your place value chart that came with your manila envelope. It has a place value chart on one side and a number line on the other side. And if you have a dry erase marker, it would be nice to have a dry erase marker for that place value chart. If you do not have one, that is okay. All right, so here on page 37, we are still talking about rounding. Last year, Tonica's Toys spent $117,290 developing a new video game. Mia rounds the amount spent to the nearest 10,000. John rounds the amount spent to the nearest 1,000. What amounts do Mia and John each round to? Okay, so we are going to use our questions that I hope you have written on a note card to help you solve math word problems. Our first question is, what is this problem about? So when I'm thinking about this, when I ignore the numbers in the problem and I'm just thinking about the problem, this is about the amount of money Tonica's Toys spent developing a new video game. So we're talking about creating a new video game, okay? What information is important? The important information is almost always going to include the numbers. So I have that. And then let's see, Mia rounds the amount spent to the nearest 10,000. 10,000 is important. And it's also important that we know that it was Mia. John rounds the amount spent to the nearest 1,000. So 1,000 is important, and it's important that we know that that was what John did. Okay. What am I trying to find out? Well, I am trying to find out what amount did Mia and John each round to. And my last question is can I draw a model to help me solve this problem? And the answer to that is yes. First, I want to point out that this says what amounts do Mia and John. That means that I have one answer and two answers to solve this problem. So anytime I'm going to solve a problem where I have more than one answer, I always put a 1 and a 2 so that way I know how many answers I need. So first I'm going to write a 1 here and say that we need Mia. And then I'm going to go down here and write a 2. And this is going to be John's answer, okay? Now to draw my model, I'm going to make a place value chart. If you have your place value chart and a marker, you can do it on there. But if you don't, then you need to make a place value chart on your paper. So here I am making my place value chart, one for each. And then I'm doing ones, tens, hundreds, thousands, 10,000s, and 100,000s. Okay, now I'm going to do the same thing for John. Ones, tens, hundreds, thousands, 10,000s, and 100,000s. Okay. Now for each of these, I need to write the number, the amount spent in the chart. So I'm going to write it here for Mia. And then I'm going to come down here and I'm going to write it for John. Okay. And now that I have my place value charts written and I have them where they are ready to go, I need to start solving. But I can only solve for one person at a time. So first I'm going to solve for Mia's. When I come back up here and look, it says Mia rounds the amount spent to the nearest 10,000. So when I'm solving for 10,000, I go and I underline the number in the 10,000s place. But I'm not going to use that number to do my rounding. I'm going to use the next door neighbor to round, and the next door neighbor is a 7. If I go back and think about my plot, or I'm sorry, my rounding mountain, and I think about how the roller coaster is going, if the roller coaster makes it all the way over here to where it's at 7, the front of it, it's already over the top of the coaster. So it's going to slide and it's going to round to the 10, which means it's going to go up. So 7 tells the 1 you have to round up. So that 1 becomes a 2. All the digits behind the 1 behind that 2 become zeros, and anything in front of it stays the same. Now I don't want to forget to bring my comma down here. So Mia rounded to 120,000. Right? Now we are going to look at John's. So John, it says John rounds the amount spent to the nearest 1,000. So I'm going to come down here and I'm going to underline my thousands place. I'm going to look next door at the neighbor, 2. So I'm going to come over here, and this is where the 2 is. That's nowhere near the top. The 2 says we're staying here. So the 2 does not say go down, it says stay. So 2 says, hey neighbor, you need to stay the same. So I'm just putting a line here to tell myself stay the same. So that means that 7 stays as a 7. All of the digits behind him become zeros, and any digits in front also stay the same. Then don't forget to bring that comma down. Now, one important thing to notice about these is there's not a label like we would normally have, but that is because if you look up here, we are talking about an amount of money. So it has the dollar sign. So Mia is not just talking about 120,000. She's talking about $120,000. So don't forget to put that dollar sign. And same with John. John is talking about $117,000. Okay, let's go to the next page on 38. I also want to make sure that you see it not just in a place value chart, but I want you to realize that you can also use the number lines that are on the back of your chart to be able to solve this problem. When you're using a number line, you've got to figure out, first of all, what you're rounding to. So in this one, it says that they're rounding to the nearest 10,000. So if it's rounding to the nearest 10,000, it's going to pick the 10,000 that's above, which would be 120,000, and it's going to pick the 10,000 that would be low, 110,000. And then it's also going to label what's halfway between, which is 115,000, just so we know where the middle is, that halfway point. Once they do that, they put the number here. So each one of these is representing 1,000. So this is 111,000, 112,000, 113,000, 114,000, 115,000, 116,000, 117,000. And it's just a little ways past the 117,000. Now, when we're rounding to the 10,000, we have to ask ourselves, is this one closer to the lower 10,000 or the above 10,000? We ignore this one that we put here in the middle because that's just to help us find the middle. We are only looking at these. So if I look here, we have a ways to go. We have quite a few tick marks to get back to 110,000. But if we go to 120, that's not very far. So 117,290 rounded to the nearest 10,000 would round to 120,000. Here's another way that you can show the answer to that using a place value chart that's different than what I showed you. On this one, you have the 117,000 for the bottom number, and then they put the 118,000 as the top number. And then they went through and they found the 10,000s place. But remember, we look next door, so we would look at the 7, and the 7 says round up. And so it would round up, except for on this one it was talking about thousands, I'm sorry. So we should have underlined this one and looked at this place. And the 2 says stay the same. So it would be 117,000 for that one. Okay. We are going to skip page 39, but that would be a great page for you to work on for some extra practice. And we're going to skip page 40, which would also be a great page for you to work on. And I'm going to go straight to page 41. This page is also another great one to work on. I highly suggest that you complete this page first, and then you come back and you watch this video to see if you got your answers right, because that will be the best way to see if you understand this. So if you need to do that, you can pause the video now and go do this page 41 and 42. That's something that you would complete in class if you were here in person. And then when you're finished with it, come back and watch the video, and I will quickly go over the answers for you. Okay, so this is going to be the answers to pages 41 and 42. I'm going to go through it a little bit quicker. Okay, round 651, 970 to the nearest 10,000. So I'm going to underline the number in the 10,000s place. I'm going to look next door. 1 says stay the same. So that means the 5 stays as a 5. Every digit behind the 5 becomes a 0. And the digit in front of the 5 stays the same. Round that same number to the nearest 100,000. So I underline the number in the 100,000. I look next door. 5 says go up. So the 6 becomes a 7, and all of the digits behind it become zeros. So it becomes 700,000. Round 45,621 to the nearest each place value given below. To the nearest 10, so I'm looking at the 2. Look next door, it's a 1, so it says stay the same. So 2 stays, every digit behind it becomes a 0, and all the ones in front of it stay the same. Now to the nearest 100, so I'm looking at the 6, I'm rounding to the 6, I'm looking next door at the 2. The 2 says stay the same, so the 6 stays the same, and each digit behind it becomes zeros, and the ones in front of it stay the same. To the nearest 1,000, so 5 is the digit I'm rounding to. I look next door at the 6, and 6 says go up because it's on halfway over the mountain. So the 6 tells the 5 to become a 6. Every digit behind it becomes a 0, and the ones in front of it stay the same. To the nearest 10,000. So now I'm rounding to the 4, so I look next door at the 5. The 5 says go up, so the 4 becomes a 5, and everything behind it become zeros. Number 3, round 452,906 to each place value given below. Nearest 100,000. So that means the 4. I look next door at the 5, and it says go up, so that 4 becomes a 5, and all the digits behind it become zeros. To the nearest 10,000. So I'm rounding to the 5. I look next door at the 2. The 2 says stay the same. So 5 stays the same. All the digits behind it become zeros, and the one in front of it stays the same. To the nearest 1,000. So I'm looking at the 2. I look next door at 9. 9 says go up. So the 2 becomes a 3. All the numbers behind it become zeros. The numbers in front of it stay the same. To the nearest 100. The 100 spot is a 0. So I look next door, it's a 6. And 6 says go up. So 0 becomes a 1. That's a little bit tricky. The 6 tells the 0 to become a 1. Then the 6 becomes a 0. And everything in front stays the same. And last, oh, I'm sorry, this was to the nearest 100, not nearest 10, so scratch that one. So I'm rounding the 9, look at the 0, and the 0 says stay the same. Everything behind it becomes zeros, and everything in front of it stays the same. to the nearest 10. This is the one that I did right there. I looked at the wrong problem. Oh, give me a second. My classroom lights went off. Okay, so the nearest 10. Now we're going to do this one. So when I look at the 0, 6 says to go up to a 1. It becomes a 0, and then everything in front of it stays the same. Okay? Now we're going to take a look at one on page 42. Okay. Here at the top. The table below shows driving distances between U.S. cities. Round each number to the nearest 100. So I'm looking at the 1. 7 says go up, so the 1 becomes a 2. Everything behind it becomes zeros, and the number in front of it stays the same. Again, I'm looking at the 1. The 3 says stay the same, so it's a 1. Everything behind becomes a 0, and the number in front stays the same. The 7 is what I'm rounding to. I look at the 1 and it says stay the same. The numbers behind it become zeros. I'm looking at the 1. 3 says stay the same. Everything behind it becomes zeros and the number in front stays the same. All right. Number 5. Look at the table in problem 4. Alex drove a distance between 2 cities in the table. He said he drove about 2,000 miles. Which cities could Alex have driven between? Show your work. So if I make a number line to show my work on this, I want to make sure that I have a number that's smaller than my smallest number. So I'm going to start with 500, and I want a number that's bigger than my biggest number, which is 2,200. So that makes 2,500 where I would end at. So then if I do a mark every 500, my number line is going to be way bigger than what I need. And it's not very even. But these should be even when you make a number line. I didn't do a very good job on that. But now I'm going to put each of these numbers on my number line. So here's 2,000 and here's 2,500. So this one would be 2,200. Next I have 1,100. Next I have 700. And last I have 2,100. And it said, which cities could Alex have driven between? So if we look here, we want numbers that are that would round to 2,000 if we were rounding to the thousands place. So the numbers that would round to 2,000 would be 2,200 and 2,100. So then I've got to match those and see which cities they are. And it's right here. So the answer is Alex could have driven between Atlanta, Georgia to Los Angeles, California, or Chicago, Illinois, and San Francisco, California. And that is your answer. Now let's take a look at this last one here. Number 6. Write numbers in the boxes below to show rounding on a number line. What place value are you rounding to? Okay, so when we look at this, we see that this one starts with an 8 and that one starts with an 8. So that means this front number has probably got to be an 8, okay? Then we've got to figure out how much space is between here. So I'm going to start right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 spots between, and both of these numbers have the 10,000 spot open. So I need to pick a number that's probably going to be between these spots. So if I choose, I can pick any number I want. So if I choose, let's choose 5 for that. But if this is a 5, that one has to be a 6 because we're between, okay? There's 10 between. That makes each of these worth 1,000. So 850,000, 851,000, 852,000, 853,000, 854,000, 855,000, 856,000, 857,000, 858,000, 859,000, 860,000. So I rounded to the 10,000s place because both of these numbers on the outsides are 10,000s. And the number I chose to round is 854,000, which rounds to, which is it closer to? It's closer to 850,000. You are going to have a different number than I do. It just depends on what number you pick here and there. That is it for lesson 2 for comparing or for rounding whole numbers. I will see you back for lesson 3.